South Korea's first lunar probe has returned some striking images of Earth and the Moon. The Korean Pathfinder Lunar Orbiter began orbiting the Moon in late December after the Korea Aerospace Research Institute spacecraft had launched aboard a SpaceX Falcon 9 rocket from Cape Canaveral, Florida in August. The probe, also known as Danuri, thanks to a public naming contest in the country that combined the Korean words for moon and enjoy, will orbit the Moon for 11 months. The stunning images captured by the probe showcasing Earth and the Moon in black and white look like something photographer Ansel Adams might have taken had he ever enjoyed such an opportunity. The orbiter is flying at an altitude of 62 miles or 100 kilometers above the lunar surface. Data collected by the orbiter will be used to inform future lunar exploration, including the Artemis program, which eventually aims to land humans at the lunar South Pole in late 2024. The probe's imagery could help with selecting landing sites for future Artemis missions, as well as mapping resources like water. South Korea signed the Artemis Accords in 2021 and collaborates with NASA on lunar exploration. The probe carries 6 instruments, including the NASA-funded ShadowCam developed by Arizona State University. Universities and research institutes in South Korea developed the probe's high-resolution camera to scout future landing sites, a polarized camera to analyze surface particles, an instrument to measure the lunar magnetic field, and gamma-ray spectrometer to identify elements in the lunar surface. ShadowCam's main objective is to take images of the permanently shadowed regions near the lunar poles that will help researchers searching for ice, mapping terrain, and watching for seasonal changes. ShadowCam is several hundred times more sensitive than the cameras on NASA's Lunar Reconnaissance Orbiter, enabling it to take detailed images in incredibly low light conditions. The probe recently used ShadowCam to peer inside Shackleton Crater, one of the permanently shadowed regions on the lunar surface. Previous images taken of this crater by the Lunar Reconnaissance Orbiter were able to spot its illuminated rim. But ShadowCam can actually see the interior, including the crater floor and the boulder tracks that rocks left behind after tumbling inside. Officials at the Korea Aerospace Research Institute, or KARI, sees the Danuri orbiter as a first step for ensuring and verifying its capability of space exploration, according to the organization. The US, Russia, Japan, China, European Union, and India have all sent missions to the moon, and South Korea wants to dive into space exploration and develop its own missions. Korea is planning to successfully land onto the surface of the moon or asteroids and make safe return, according to the institute. Korea is expecting to achieve strategic space technologies. Additionally, South Korea will become just one of a handful of countries to have sent a mission to the moon. Everybody is so happy and excited. Kyung-ja Kim, a planetary geoscientist at the Korea Institute of Geoscience and Mineral Resources in Daejeon, and principal investigator for one of the craft's instruments, tells Nature's News, Smitri Malapati. It's just so cool to see more and more countries sending up their own orbiters and adding to the global understanding of what's going on the moon. Rachel Klima, a planetary geologist at the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland, who is part of the research team, tells Nature News. The craft's wide-angle polarimetric camera, or PolCam, will contribute to estimates for when surface impacts and geological processes took place by gauging the angles at which light bounces off lunar surface particles, a measurement process called polarimetry. The polarimetry reveals the size of particles to scientists, which in turn indicates how long a particular crater or surface feature has existed, per Science Insider. We were surprised to learn that no previous mission has done lunar polarimetry from a lunar orbit. Chae Kyung-sim, a planetary scientist at the Korea Astronomy and Space Science Institute and a member of the project's principal investigators team, tells Science Insider. It's a groundbreaking instrument. William Farron, a planetary geologist at the Space Science Institute in Boulder, Colorado, tells Nature News. Farron will be studying the data and hopes the probe's measurements of volcanic ash can help scientists learn about lunar volcanic eruptions. Some parts of the moon don't receive any sunlight, which of course makes them challenging to image. ShadowCam, the one NASA instrument on the mission, will search for evidence of water ice at the moon's poles and determine how future rovers might traverse craters and depressions on the surface, per space.com. ShadowCam will peer into the moon's deeply shadowed areas to provide the first ever high-resolution look into the lunar permanently shadowed regions, per Sun Mahanti, Deputy Principal investigator for ShadowCam at Arizona State University in Tempe, tells Space.com. There's a treasure trove of solar system data locked away in the layers of permanently shadowed craters, Klima tells Science Insider. The United States, Japan, Russia, and the United Arab Emirates all have at least one moon mission scheduled to launch before the year's end, per Science Insider. Besides, the rise and fall in the strength of the magnetic field in the solar wind induces electric currents in the moon, and those electric currents, in turn, generate magnetic fields that will be measured by Danuri. The characteristics of the magnetic field will give hints of the structure and composition of the moon's interior. This work also requires combining measurements with those made by two NASA spacecraft, Themis-Artemis P1 and P2, which travel around the moon on highly elliptical orbits, so they can measure the changes in the solar wind, while Danuri measures the induced magnetic fields closer to the surface. What we will learn from that is a kind of a global map of the interior temperature and potentially composition and maybe even water content of the deep parts of the moon, Dr. Garrick Bethel said. Scientists will use another of the Danuri's instruments, a gamma-ray spectrometer, to measure quantities of different elements on the moon's surface. The Danuri's device can pick up a wider spectrum of lower energy gamma rays than similar instruments on earlier lunar missions. And this range is full of new information to detect elements on the moon, said Naoki Yamashita, a New Mexico-based scientist who works for the Planetary Science Institute in Arizona. He is also a participating scientist on Danuri. The Korean Aerospace Research Institute, South Korea's equivalent of NASA, will use Danuri's high-resolution camera to scout the lunar surface for potential sites for a robotic lander mission in 2031, Mr. Kwon said. A second camera will measure polarized sunlight bouncing off the lunar surface, revealing details about the size of particles that make up the lunar soil. Due to the consistent bombardment of solar wind, radiation, and micrometeorites resulting to soil particles from a lunar crater breaking apart, the probe's instrument could give an estimate of its age, say in the case of smaller grains, that would suggest an older crater. The polarized light data will also be used to map abundances of titanium on the moon, which could one day be mined for use on Earth. NASA supplied one of the cameras, a shadow cam, which is sensitive enough to pick up the few photons that bounce off the terrain into the moon's dark, permanently shadowed craters. These craters, located at the moon's poles, remain forever cold, below minus 300 degrees Fahrenheit, and contain water ice that has accumulated over the eons. The ice could provide a frozen history of the 4.5 billion-year-old solar system. It could also be a bounty of resources for future visiting astronauts. Machinery on the moon could extract and melt the ice to provide water. That water could be broken apart into oxygen and hydrogen, which would provide both air to provide for astronauts and rocket propellants for travelers seeking to travel from the moon to other destinations. Moreover, South Korea has an extensive military missile program and has placed several communications and Earth observation satellites on low Earth orbit since launching its first in 1992. And it has been expanding its domestic rocket launching capability so that future missions may not need to rely on SpaceX or on other countries to get on space. The Korean Aerospace Institute successfully placed several satellites in orbit with the second flight of Danuri, its homegrown rocket. We will take on challenging projects such as lunar landers and asteroid exploration, Mr. Kwon said.